One, great. So what are we going to be doing today? So as usual, I'm going to give you a roadmap so that you understand what's exactly happening in our little classroom. Okay. So first, we're going to be continuing with chapter number 5, acid, bases, and salts. Last time we saw what acid is, what a base is, and what salts are. We're not gone into depth with salts, but we'll go in the next lecture. Okay. And we saw what neutralization is, what ionic compounds are, what is dissociation, etc., etc. So with this, keeping this in mind, we're going to be starting with first is what is reactivity and right way of writing chemical equations. So this thing you have learned in 8th standard actually, how to write chemical equations, because I asked you last time. But I just feel that this is a part, this part should be, everybody should know how to do it. It's nothing, it's not rocket science. And what is reactivity? We start from the basics, because why is because we're going to be learning about reactivity of acids and bases. So first of all, before learning about that, we have to know what reactivity is, right? So I'm going to be starting from there. And then there are four labels, I think, which we have to learn. First is neutralization, which you have a fair idea about what it means. We saw a video on it as well in the previous lecture. Then the second is reaction of acids with metals. So what happens if I put a metal in an acid? Okay, so what is going to happen? So that's the second thing. So third is the reaction of acids with oxides of metals. So if I have a metal and I have an oxide, like a metallic oxide, sorry, and I put in an acid, what is going to happen? And the fourth and last one is the reaction of bases with oxides of non-metals. So this again, it's basically ulta of the third point. Instead of just reaction of acid, it's reaction of bases with oxides of metal and here oxides of non-metal. So these are the four things we're going to be doing. And why are we doing this is once you understand how acids, metals, bases, they all react with each other, in the future, what you can do is if I give you two compounds, okay, and I tell me the solution, what it could be. So you can write it down as we write down problems in mathematics, and you can give me a solution. Like we can predict what is going to happen. And this skill is very important if you are going to do, if you're going in the industry, if you're doing chemical engineering or whatever, because sometimes what happens is these chemicals, they're highly reactive. Okay, so things can go south pretty quickly. So for that, what scientists do is they on paper first test what is going to happen with the rules we know. So once you have the theoretical backing, then they go into the lab and perform those experiments, because then they understand what precautions to take. Okay, so this is the reason we are learning this as to what exactly could happen. Okay, so we're just predicting it with basic. It's like mathematics basically. So this is what we're going to be doing today, basic roadmap. So I'm going to go ahead now with the first point for today. Just a minute. Yeah, reactivity. So I'm going to request someone to come off mute whose voice I haven't heard in a long time. So let's say Sandesh, if you're there, can you just read what's written on the screen for us?
भैया आवाज आ रही क्या?
Yeah, Sandesh, I can hear you. Go ahead.
The relative capacity of an atom, molecule, or radical to undergo a chemical reaction with another atom, molecule, or compound.
Thank you so much, Sandesh. So what is reactivity? Now, if I say that something is highly reactive, what do you understand this? Like you might have a little understanding of what this word means. So if you do, just in the chat box, tell me what do you understand by this. Meanwhile, I'll explain it to you from my side. Is that reactivity is nothing but if I have two compounds. Okay, let's say I'm going to just annotate on the screen. I love annotating on the screen. So let's say I have one compound like this, and I have a beaker and have some liquid. Okay, so let's say this is water. Okay, and this is sodium, Na, sodium metal, which is solid. Okay, I just plop it into this beaker, which you shouldn't do, but let's say, okay, we just do this H2O, this is liquid over here. What is going to happen now? So what happens is Na, sodium is a highly reactive metal. So it's going to react very violently and very fast, okay, with water to form what? NaOH, right? So, or Na2O2, sorry. So basically, it's going to form Na2O2. And what happens is like the reaction is so fast and so violent, it's like a explosion, like a proper explosion happens. If you have time after this lecture, just go on YouTube and search sodium put in water. Okay. And then I'm wonderful, like millions of views these videos have. It's a highly reactive, reaction, and it happens extremely fast. So let's say I'm going to write extremely fast over here. So these two compounds over here, or this metal and this compound, they react extremely fast with each other. They bind to the water, and the chemical reaction is explosive. Okay, explosive. I'm just going to write this. Okay, so this is what happens when sodium is put into water. But on the other hand, let's take an example. Forget sodium. If this is not sodium, this is a rock. Okay, let's say this is a rock with a rock you just take from the street or something and put it in water. What's going to happen? That nothing is going to happen. Like immediately, nothing is going to happen. Slowly, it might, but immediately, let's say I put a rock in water. What's going to happen? The rock is going to get wet, right? That's the maximum thing that can happen in under 5 minutes. So this is what we say is very slow. So rock and water they're not reactive. They're very lowly reactive. They're very less reactive. So reactivity is nothing but if you have two compounds or 2, 3, 4, how many n number of compounds you want to take, and you mix them together, the speed and the intensity with which the reaction is going to happen is nothing but a reactivity. If the speed and intensity is greater, we say that they are highly reactive. If the speed and intensity is very less, is very slow, we say that they are not that reactive. Okay, they are unreactive. All right. So this is what reactivity means. I have actually a photo over here. Yeah, okay. So what is this element, folks? Everybody knows it's written on the picture over here. So just quickly, this is gold. Gold. Everybody knows what gold is. It is one of the the worst reactive metals ever because it doesn't react at all. Gold. And on the other hand, this is sodium. Okay. So this is sodium metal, Na. Potassium along with sodium are the most reactive metals on Earth. What happens is that sodium is stored in a kerosene jar. Okay, so for example, I just had it quickly. Let's say I have a beaker over here. It's not even a beaker, it's actually a vacuum tube. But for simplification, I'm just gonna draw this. So this is kerosene, okay, not water, kerosene, and sodium. These chunks you can see over here, they are put in this because sodium and kerosene, they don't react. Okay, why is this so? Is that if you are in a lab, you can't store it directly under air, or just like if I have a table like this, I take sodium metal from my pocket and keep it here. It's not going to happen. It's going to violently react. It's going to explode. Basically, explosion hone wala either. You must have burst firecracker sometime. Like you shouldn't do that, but if you might have had, in the past, the same thing is going to happen. If you just put sodium in air, if you just take it out, it's going to explode. Again, if you put it in water, it's going to explode. So sodium is highly reactive. On the other hand, if you take gold, if you take a bar of, or if you take jewelry of any sorts, and you take it down in the air or put it in water, what's going to happen? Nothing, right? Because everybody wears gold on their body. So gold is it's not at all reactive. On the other hand, sodium is reactive. So I hope you are getting the point of what reactivity is. It's the intensity and speed, how fast it's going to react with another compound. Okay. So if you're clear with this, give me a yes in the chat box. What reactivity means, right? So that I can go ahead. Oh, I forgot to check the chat box, but Radha has put that an expression immediately for an action done by, yeah. So basically it is a very fast and immediate action to, chemical reaction. Great. So I can see a lot of yeses in the chat box. I'm going to go ahead. Great. You have understood what reactivity is. So with that in mind, oh, and this is actually what happens if you put it in water, sodium, sorry, is not Na2O2, that's in oxygen. This is Na plus H2O gives NaOH, sodium hydroxide plus half H2, which is hydrogen gas. So this is the reaction which you get, and it's very violent. You can see it on YouTube. I'll actually send you links about that. It's very, interesting. Karan, you're asking, can sodium react to the atmosphere? Absolutely. So if you take sodium is stored under kerosene. So if you take sodium and just, bring it in the atmosphere, like kuch bhi nahi, just hold it in the air. I won't suggest you to do that. It's going to explode. The moment it touches oxygen in the air, in the atmosphere, sorry, it's going to explode. So it's highly reactive. That's why it's kept under kerosene. All right. So this is basically the reaction of sodium under water. So next part, we're going to go to reactivity of acid and bases. So folks, now once you have understood what reactivity is, what we're going to be doing is reactivity. So what we're going to be doing is we are going to do various permutations combinations. So what I'm going to do is I'm just going to, let's say I have an acid with me and I mix it with a base. Okay. What is going to happen? So that prediction we are going to be studying. We're just going to be studying the predictions. Actually, these reactions have been done by chemists for hundreds of years now, but we are learning it for the first time. So predictions. Okay. So now what is going to happen? So now, okay, now you folks know what neutralization is. So anyway, I'm going to request someone to read what's written on the screen quickly in like 2 minutes. And Neeraj, if you are there, just read what's written on the screen for us. So we can go ahead.
Neutralization is a chemical reaction in which acid and base react quantitatively with each other to form salt and water.
Thank you so much, Neeraj. So yeah, neutralization is a chemical reaction in which acid and a base react quantitatively. So what does quantitatively means is their quantities should be similar to each other. If you want a complete neutralization reaction, okay, their quantities should be similar or same, identical, whatever, with each other to form salt and water. So this is something which we have done earlier. So I have a wonderful photo about this. Yeah. So here we can see on the screen we have HCl, which is hydrochloric acid, plus NaOH, which is sodium hydroxide. We mix them together like this, and we get H2O plus NaCl. NaCl is nothing but salt, which we eat every day. It is common salt, and H2O is nothing but water. So we know what neutralization is, but we have to understand how does it exactly happen. So why do we get water? Okay, what's the reason behind it? Why do we get a salt? What's the reason behind it? So this is what we're going to be learning today. And this is actually, it's bang on, it's very important. So let's go ahead. So this is the reaction actually. So I'll explain it to you. Okay. So what happens is that, let's say we have a beaker over here. I'm just going to change the color quickly. Wait a minute. So we have a beaker of HCl, hydrochloric acid, and NaOH, which is sodium hydroxide. This is an acid, this is a base. And over here, I have a beaker like this. Okay. And what I do is, so what I do is, in this beaker, I pour HCl. So let's say HCl is in this color. I pour HCl like this. And in the same beaker, same quantity, I pour NaOH like this. Okay. So what is going to happen is, when acid and base react, you can see down here, okay, HCl is going to break. So we have learned about ionic compounds, right? So it is known as dissociation. So it's going to dissociate into anion and cation. So H plus Cl minus is what we get. And over here, NaOH, the same principle is going to happen. NaOH is going to break into Na plus OH minus. So Na plus like this. This is an arrow. Okay. Yeah, Na plus OH minus over here. Okay. So this is what is going to happen. Now, if you look clearly, people, we have OH minus over here and H plus over here. So what is going to happen is they're going to be attracted to each other like this. Okay. They're going to be attracted to each other and they're going to form a bond. And this is where this is written over here. So what is going to happen is H plus OH minus, they're going to combine with each other. Okay. And if you combine H plus OH minus, what's going to happen? We have 2 hydrogen over here and 1 oxygen. What we get is H2O. And H2O is nothing but what? Water, right? So this is how we get water when we mix an acid and a base. The hydrogen ions and the hydroxide ions, they combine with each other to get water, okay, H2O. So this is how we get H2O. Nothing but the acid and the base, they dissociate. Out of that, the H plus ions and the OH minus ions, they combine with each other to form water. And the remaining thing is nothing but Na plus and Cl minus. So now this is plus, this is minus. Valence is also 1 and 1. So what's going to happen is that they're going to combine with each other now to form nothing but NaCl. And why do we call it a salt? Is nothing but it is neutral it's neutral basically. So it doesn't have any hydroxide ions. It has no H plus ions. What is remaining is nothing but pure compound, and it is not at all positively or negatively charged. Is because there is only 1 plus and 1 minus over here, so they're going to cancel out each other like this. And we learned about this in the very first lecture when I taught you about what is an atomic number, what is the electronic configuration, and what happens. So this is how we get NaCl, which is neutral. There is no charge on it. Okay. So now just imagine if I have a compound with no charge and if I have water, okay. So I get something which is neutral. It is not acidic, neither it is basic, right? So this is why we say that a neutralization happens when acid and base mix together. So acid plus base. So I'm just gonna quickly write it like this. So acid plus base, we go down. The dissociation happens. Dissociation. It's so difficult to write with the mouse. So dissociation, and it dissociates into ions. Sorry, not ionic compounds. So let's say ions. So we get positive ions and negative ions over here. Negative ions, and we get H plus and OH minus. So because of dissociation, we get all of this. And because we get this, what happens is the next step is nothing but H plus and OH minus combine. H plus plus OH minus, they combine. And the positive and the negative ions we have got over here, they combine together. Positive and negative combine together. Negative. So this becomes neutral and this becomes water. Okay. So that's why we get H2O plus salt when we mix acid and base. So this is basically a 4-step process. And if you go deeper into it, it's actually pretty interesting, but you don't have it in your syllabus right now and you don't even have time to cover it. So if you are interested in, just text me, I'll send you videos about this. They're very interesting videos. So folks, this is basically what happens when neutralization is done in acid and base mix. So if you have any questions, raise your hand, ask me, or put it in the chat box so that I can clarify your doubts. So I'm going to wait for 10 seconds more. If not, then I'll go ahead. And Vishal, you have asked me, Bhaiya, what will happen if we put less water and more salt in a beaker? Okay, so let's do a thought experiment. I have very less water and I have a lot of salt. So what is going to happen is salt is going to get dissolved in water, but a lot of salt is going to just be, it just stay there, is because the amount of salt that can be dissolved in that amount of water, it's going to reach an equilibrium. And after that, the remaining solid particles is just going to float. So rather than putting yes, so I think you have understood. Rest of you, if you have understood this, give me a yes so that we can go to the check for understanding. So yeah. So only one yes in the chat box. So I have to know that you have understood. Yeah. So Payal is also giving me yes. 2 more people, Sakshi, Vishal. Okay, thank you. So I'm going to go ahead with a small nothing but. Okay, yeah, I forgot. So this is also a small neutralization reaction that I had. This is known as bromine, okay, BRH plus KOH is potassium hydroxide. They mix with each other. And what happens is, just a minute, OH and H, they combine together like this to get water, and Br and K, bromide. So this and this, bromine and potassium, they mix with each other to get KBr, potassium bromide. Okay. So this is nothing but another neutralization reaction which I had. I clearly forgot. So yeah. Great. So we have a little check, folks. So first question is very easy. If I put a base in an acid, what would I get? So any one of you just come off mute and answer. These are the 3 questions which I have posted on the screen. One by one, just come off mute and answer these. If not, then I'm going to cold call because I'm very shameless that way. So yeah. Who wants to answer the first question? Just read the question on the screen and then answer it. Okay.
Can I?
Go ahead.
Salt and water.
Absolutely. Yeah. So we just learned it like 1 minute ago. So thank you so much, Sakshi, for that. If I put a base in an acid, what would I get? Salt and water. So second question, does anybody want to answer? Radha, I saw you raise your hand. So was that for the first question or just start the second question?
Okay. So hydrogen combines with oxygen to form dash.
Yeah. Think about neutralization. What is happening?
They are forming a They are forming a reaction, right?
Okay, no problem. So folks, what happens is that it forms water, and if you want a proof of this, you can always, if you've ever seen SpaceX launch of a satellite, of a launch of a rocket, what happens is that there is a lot of energy which is going in the downward direction, Newton's third law, And what happens is that water is formed because there is hydrogen and oxygen fuel which combines to form water. It's another topic for another day, but yeah. And the third question, people, the last one is, this is an incomplete equation I have written on the screen. It is nothing but a neutralization reaction, okay? Why? Is because we are getting water over here and KNO3 is nothing but a salt. So HNO3 plus dash gives KNO3 plus H2O. So if you can reverse engineer this, and give me the solution to this, it'll be amazing. If not, then I'll teach you, because I told you in the second slide itself that I'll teach you how to write chemical equations. So, okay. So if you can't do this, give me a no in the chat box so that I can tell you how to solve, say, fill in the blank equations. It's pretty interesting. Okay, any one of you? Okay, so I'm just gonna go ahead. So let's say we have HNO3 over here. Okay, HNO3 plus dash gives KNO3 plus H2O. Okay, so first and foremost, we have to look for the kind of elements that are present in that. Okay, elements or compounds. So I'm just gonna change my color over here. Okay, so let's say on the left hand side we have HNO3, of which NO3 is present over here. Okay, so NO3 is done. Now on the right side we have K, but I can't see K over here anywhere. Okay, I can't see K over here. So what I'm going to do is I'm going to write K over here. I say, all right. So I have written K over here. So K is also gone. So now what is remaining is, look at the extra things, people. Look at the extra things which are remaining. I have one H which is remaining over here, and I have two H and one O which is remaining over here. So what the basic principle of writing a chemical equation is, the number of molecules which are present on the left side, matlab LHS, has to be equal to the number of molecules that are present on the right side, RHS. So for example, let's say I have one H over here, one N over here, and three O over here, okay, 3. And I have on the right side one K, one N, 3 O, 2 H, and again one O, okay. But now what I've done is I've accounted for this N over here by looking on the left side. I've accounted for these 3 O over here by looking on the left side. So these two are done. Now 1K is remaining. So I just wrote 1K over here. So this is also done. So now what is remaining is that we have one H over here, but we have 2 H and 1 O over here. So I can just, cut one H over here from here and just write 1 because I have 1 over here. So this is done. So what is remaining is that I have one H and one O remaining. So nothing but I'm just going to write KOH over here, which is nothing but potassium hydroxide, which is a base. All right. So with this, now if you look, now just look around, look to the equation and just see what is going to happen. Now do this tally again. Okay. So in accounting, there is something as tally. So let's do a tally over here. We have one H over here. Okay. One N again, 3 O, 1 K, 1 O, 1 H, again 1 K, 1 N, 3 O, 2 H, and 1 O. So let's start from the left side. So 1 H is gone. Let's say 1 H is gone. So 1 is remaining. 1 N is gone, 1 N is gone, and 3 is done. 1 K is done because K is over here. So what is remaining? O and H. So O is also gone. So O is gone, and we have 1 H remaining. So this is also gone. So this chemical reaction is chemically stable. Okay. So the answer is KOH. So henceforth, people, if you ever have a fill in the blank equation, just use this method. The technicalities are not important right now. You can use this method to just find the answers. The reasoning behind it is, I'll tell you sometime else. Okay. There's a lot of reasoning behind it. It's not as simple as it seems. All right. So this is the way we solve chemical equations. All right. So if you understood this method of tallying, give me a yes or a thumbs up or whatever in the chat box, so I can go ahead. Okay. Great. So we'll practice this even more. This is pretty interesting. So Shubham Payal Prince, thank you so much. Isha, you haven't understood. So let's do one thing. In the next check also, we have 3-4 equations like this. So we'll solve them together. By the end of this lecture, you'll understand how it goes. Okay. So we go to the next step, people, which is reaction of acids with metals. So I'm going to request again someone to, read this for us. So let's say, Gauri, if you are there, can you just read what's written on the screen for us?
Reaction of acids with metals. The reaction of acids with metals is determined by the strength and the concentration of the acid, and also by the reactivity of the metal and the temperature. It is easy to bring about the reaction of a dilute solution of strong acid with moderately reactive metals at normal temperature.
Thank you so much, Gauri. So people, as always, I'm just going to divide this into smaller parts. So reaction of acids with metal. So what we are doing right now, I have an acid right now like this in a beaker. I have a metal like this. I'm just going to put it in there. And what is going to happen? We are going to predict it. Okay. So this is what we are going to be learning today. So the reaction of acids with metals is determined by strength and concentration of acid, and also by reactivity of the metal and temperature. For what it basically means is, if I have an acid, how strong is that acid? And if I put a metal in it, will the metal react or not? So if it's an unreactive metal, it has no interest in reacting with the acid, nothing is going to happen, right? So this is known as the reactivity of the metal. And the temperature actually imparts energy. Okay, second law of thermodynamics. So basically, temperature, what it does is, it gives energy to the molecules to react more. But just have to keep it in mind that more the temperature, more the reactivity is going to be. In this case, okay. So this is what it does. And it is very easy to bring about a reaction of a dilute solution of strong acid with moderately reactive metals at normal temperature. So what a dilute solution is nothing but, there are two types, dilute and concentrated. So can anyone tell me what does concentrated mean? You must have heard it somewhere. If you have a faint idea about what it means, just tell me. Concentrated. Concentration. Yeah.
Focused.
Yeah, focused. Yeah, the focus is actually the meaning of it. In chemistry, what it means is, concentration means, so let's take for example, we have 1 liter of hydrochloric acid, okay, 1 liter of HCl. Now I have a beaker like this. I have two beakers. And in one beaker, I have just 1 liter of water. So in this beaker, I only have 1 liter of H2O. Okay. And in this beaker, I have 1000 liters of H2O. 1000 liters of H2O. Now what I'm going to do is, I'm going to pour this 1 liter of HCl in this beaker, and also I'm going to pour 1 liter of HCl in this beaker. Now you tell me, will the quantity, like will the concentration of HCl be same in both the beakers? One we have 1000 liters and one we have 1 liter. Okay. Will it be same? No, right? Shubham is saying no. So obviously, because water is only 1 liter over here and HCl is 1 liter. So this solution is going to be concentrated. Why? Because the solvent is very less. Solvent means in which we are dissolving it. So H2O is very less. But in this case, H2O is more than the thing we are trying to dissolve. So it is going to be diluted. Okay. So this is nothing but concentration and dilution. Dilution is you reduce the strength of that acid or base. Concentration is you increase it. Okay. So this is the basic understanding. If you understood what concentration and dilution is, give me a yes in the chat box, because this is, nobody's talking anything. So I have no idea what's happening. So yeah. Shubham is saying yes, Radha is saying yes. Rest of y'all, Pratham is saying yes, Bhumika is saying yes. All right, thank you. So I'm going to go ahead with the second point now. We have understood what dilution and concentration is. So what happens when our acids react with metal? Okay. So we have seen that where acids react with bases, we get salt and water, which is neutralization. Same way, if a metal and a dilute acid, okay, this is very important, dilute acid, they react together. We mix a metal and a dilute acid, what we're going to get is salt and hydrogen gas. So this is an example of it. Magnesium, which is Mg, plus 2HCl, which is hydrochloric acid, aqueous. This is very important, people, aqueous. Aqueous means it is dissolved in water. So that means it is dilute. Gives MgCl2, which is nothing but a salt, plus H2, which is hydrogen gas. Now how does it happen now? So I'm going to write it over here. So this is the basic thing which happens when acids react with metals, dilute acids react with metals. So Mg, which is nothing but magnesium, is a solid. Okay. And plus, let's write HCl over here. Now, people pay attention because this is how we write chemical equations. Okay. So what is going to happen is Mg and Cl, they're going to combine together. But we know that Cl, chlorine ka valency or atomic number. So 288, if you want to complete its octet, it needs 1. And magnesium can give 2. So what is happening is Mg and Cl, they combine. But this magnesium needs 2 electrons to complete its, its orbit. So we write MgCl2 plus H2. Hydrogen is stable only in H2 state. So we write H2 over here. But now let's again compare. Okay. So we have one Mg over here. We have one Cl, we have 2 Cl over here. Okay. And we have one H over here, we have 2 H over here. So what I'm going to do is simply going to write 2 over here. So now if we compare these two equations, what is going to happen is nothing but they're going to be stable. So this is a stable chemical equation now. So yeah. So what is basically happening is if I mix a metal with a dilute acid, dilute is very important over here, I get a salt and hydrogen gas. So if we ever are in, a lab, I just, hope we are in the lab to do these experiments in school. So burning of H2 with an explosion. So what happens is that you just have to take a test tube like this, put HCl, aqueous HCl. So HCl plus water, hydrochloric acid plus water, put it in this and put a magnesium strip or, dots, strips of little magnesium over here and seal this thing over here. Seal this as a cork bitha over there and make a hole in it, put a pipe in it, glass pipe. What is going to happen is that magnesium chloride is going to get formed, which is going to dissolve in the water, and hydrogen gas is going to escape. SSSL. So if you ever do these experiments, folks, what you can do is just take a matchstick like this and put it near, this opening. What is going to happen is you can hear a pop sound, an explosion kind of thing. Why? Is because hydrogen is very reactive to heat, like it explodes immediately when it reacts with oxygen and everything. So this is what is going to happen, and you can hear a pop like this. So if you look into this, look at this diagram over here, you can see that you have put magnesium ribbon into this and dilute HCl is over here. Hydrogen gas will escape, and you can hear the pop sound like this over here. And the magnesium chloride, the salt is going to get dissolved in this solution. So this is how a reaction of acids with metals happen. And now I have a little question for you, and we will solve this together. As Isha, you also said that you had a question with regards to how to solve chemical equations. So yeah, so we will do this together. Okay. So first and foremost, let's look at the information we have. So first information we have is dash solid plus dash aqueous react together to form CuNO3 twice, aqueous plus H2 gas. Okay. So now I know that H2 is a gas and CuNO3 twice is nothing but a salt. So this means that this first thing is going to be a metal and the second is going to be a dilute acid. So now let's reverse engineer this. Okay. So now let's check on this left side and the right side. So on the right side, I have one Cu, one N3O multiplied by 2. So I have this twice plus H2 over here. So my metal is obviously going to be copper. Cu is nothing but copper. So Cu is done. And if we reverse engineer this, we can see that we get HNO3 over here. HNO3, which is an acid. Okay. But now we have NO3 is there over here twice. So I'm just going to write 2 HNO3 because we have 2 hydrogen over here. So now if you look at this reaction, we can see that Cu is one as a 2H is done and 2 NO3 is there, NO3 twice is there. So this is how we get copper plus HNO3 gives CuNO3 twice plus H2 gas. So this is basically acids with metals ka reaction. There are many more such reactions in your textbook. So I'll request you to go through page 68 to 74 if you have any queries about this. All right. So, okay, folks. So if you understood this, give me a yes in the chat box. If not, come off mute and ask me, any queries. I don't want you to go home with any doubts or anything. Okay.
Bhaiya, can you explain dilute word again?
Yeah, absolutely, no problem. So just a minute. Folks, dilute means nothing but, just a minute. I'll just make space over here. Yeah. So dilute is nothing but, it is the amount. Let's say we have a thing, like let's say we have metal. Okay, metal or salt. Okay, salt will be easier to explain. So I'm going to take salt over here. Okay, we have salt, and let's say we have two beakers over here, beaker or water bottle or whatever you want to call it. Okay, in this, and both of them have 1 liter of water. Okay, 1 liter of water in that bottle. We have both in this bottle. Okay, like this and over here. Now I have salt. Which salt do I have? NaCl, common salt, which we eat. So let's say I take 1 kg of salt in 1 liter of water and I put it over here, 1 kg of salt, and I try to dissolve it. Okay. On the other hand, I just take 5 grams of salt, 5 gram, yeah, and put it in this water over here. Mix it well. Okay. So now, folks, tell me, if I drink both of these, both of the water from these beakers, what is going to happen? This beaker over here on the right side, this beaker, its water is going to taste very salty. Yeah. And this beaker, its water is not going to taste that salty. It will be, but very little. So the difference between dilution and the concentration is nothing but the amount of substance we have put in a solvent, or the amount of substance you can think about put in water. So this 1 kg wala salt ka beaker is very concentrated because the amount of salt in it with respect to water is very high. So you can also say it as salt over water, salt on water ka jo ratio hai. It is very high. But in this beaker, we just put 5 grams in 1 liter. So I'll say that this is dilute compared to this beaker. Okay. So this is the differentiation between dilution and concentration. We say something is dilute if that substance is not present, there's not much concentration of it or something like that. So Radha, if you still, have I cleared your doubt, or if you still have any doubt, just go ahead and ask me, okay?
No, clear.
So, okay, great. Folks, with this, I'm going to the third checkpoint. And these are the 2 questions we have. The first question, we had it right now in the screen before. So I'm just going to request someone to come off mute, read it for us. And if you know the answer, just give the answer, okay? So Siddiqui, if you're there, just quickly read the first question for us. Anyone, Siddiqui, are you there with us right now? If not, just give me a thumbs up or something.
Can I read, Bhaiya?
Go ahead.
The reaction of acids with metal is determined by the strength and the intensity intensity of the acid, and also by the concentration of the metal and the temperature.
But actually, rather, you're partially correct. So what I'm going to do is concentration of the acid over here, reactivity of the metal. Okay. The answer is like this. Now the second is look at the incomplete equation and fill in the blank. Zn plus something gives ZnSO4 plus something. Okay. So now folks, remember we are talking about hydrogen. So let's say I have Zn, which is zinc. Zinc is Zn plus dash aqueous, which is going to be a dilute acid, gives me ZnSO4. I'm going to write it properly over here. Zn plus something gives me ZnSO4 plus dash. So folks, we know that we are talking about reaction of acids. This is an acid, this is a salt, this is a metal. So obviously I'm going to get hydrogen gas over here. Okay. So now with this in mind, tell me what compound will I get over here. Just use your heads. Use the tally method. I have 1 zinc, 1 sulfur, 4 oxygen and 2 hydrogen over here. 1 zinc is complete, 1 zinc is complete. What is remaining is nothing but SO4 2. So I can write H2 SO4, which is sulfuric acid over here. And if I tally it again, everything is right. So we get H2SO4. So zinc plus sulfuric acid gives us ZnSO4, zinc sulfate plus hydrogen gas. Okay. So this is how the reaction is. Great. People, we come to the second last slide of today. Or let's say we'll keep it last slide of today, whatever, it's up to you. Okay. So we come to the last slide of today. Quickly, read. I'll request Prince to read what's written on the screen for us.
Insoluble oxides of metal react with dilute acids to for soluble salt and water.
Absolutely. Thank you so much. So people, insoluble means which cannot be dissolved. Oxides of metals react to dilute acids to form, it should be form over here, soluble salt and water. So basically what it means is, I have a metal oxide, I have dilute acid, put it together, I get salt and water. I don't get hydrogen gas, okay, I get salt and water. How is that? Fe2O3 ferrous oxide plus 6HCl gives ferrous chloride plus 3H2O. So there's nothing but reaction of acid with oxides of metal. If you look closely over here, it is oxide, we have oxygen. So any metal which is combined with oxygen is known as an oxide. Okay. We get salt, which is ferrous chloride, and 3H2O, which is water. So this is the basic working principle of it. All right. So this, folks, you have to just keep it in mind. You have to learn this ratta marna iska. Insoluble oxides. Insoluble means which cannot be dissolved. Which cannot be dissolved. Oxides of metal react with dilute acids to form soluble salt and water. So what happens is that if I put an insoluble oxide, Fe2O3 in 6HCl, I'll get a salt, FeCl3, which is soluble. So ये water में dissolve हो जाएगा. Alright. And 3H2O. So you just have to keep this in mind. There is nothing, there's no mathematics to it. Just keep it in mind that if I have a metal oxide and if I have a dilute acid, I'll get salt and water. Okay. Great. So folks, I'm going to go to the last slide of today. Is the check. So there are the 3 questions I'm going to put, and you just have to think. Okay. So the first question, can anyone, if Radha, you can just read on what's written on the screen and give us the answer, or I'll help you in this answer. Okay. So yeah, can you just read?
Yes. So the first question is, one is written and then there is a dash, oxides of metals from soluble salts and water. Insoluble होगा क्या भैया?
Absolutely, Radha. You're correct. Insoluble. Kimaya, you can leave. Okay. Second question I'm going to ask people is, are metal oxides basic in nature? मतलब metal oxide base है क्या? Basic है क्या? Think about it for a second. Okay. Let's go to the previous slide. Think about it. Okay. Okay. Just everybody. Yeah. Right. Yeah. So people think about this for a second. Are metal oxides basic in nature? What is your answer? Is it basic or not? Look at this chemical reaction and tell me. Think for a second. Are they basic or not?
Yes.
Bhaiya,
Bolo.
yes, because metal oxide and dilute acid form salt and water. So if dilute acid is acid, then metal oxide will obviously be a base. So it's
Absolutely.
basic in nature.
Yes, exactly. So absolutely on point. And I can also see in the chat box when people are saying basic, and Shubham and Sandesh were telling us. So yeah, absolutely. They'll be basic in nature because like, you can see acid to hai, either basic, we get salt and water. All right. That's why they are basic in nature. Great. So we go to the next point now is the check. So we have, answered 2 questions. Now we'll answer the last question for today is Al2O3, aluminium oxide plus hydrofluoric acid gives dash. So now people, you have to work with me. I'm not the only one who's going to solve this. Now tell me what will happen. Okay. step by step. First, let's write the equation over here. Al2O3 plus 6HF. So if you look clearly, hydrofluoric acid is an acid. So this is a metallic oxide. So we know that metal oxide plus acid gives a salt, which we don't know what it is, plus water. So I can write H2O over here. So now nothing but use the tally method. I have 2 aluminum, 3 oxygen, 6 hydrogen and 6 fluorine dash. I have 2 hydrogen and 1 oxygen. So now obviously I need aluminum over here. So I'll write aluminum over here. Okay. Also I need F over here. So let's say I write F over here. So I get aluminum fluoride. Okay. But now we have to see to it that we stabilize the equation. So how do we do it? So for that, I think you have to know the atomic numbers and everything. But it's okay for today. So it is nothing but AlF3. The reason is because aluminum ka valency 3 hai. What is valency? I'll tell you later on. Now you just have to write 2 over here to stabilize the equation. And folks, actually what I'm going to do is, next lecture I'm going to take something known as basics of chemical reactions, because I can see that most of you don't know what it is and how to solve them. So I'm going to take everything from valency to stabilization to ionization. Not in your syllabus, but it is very important for you to know. All right. So with this, we come to the end of the lecture. I just have a little homework for you. So this is the IP you have. This is individual practice. I'm going to request someone to take a screenshot of this, post it on the group. You have until tomorrow 5 p.m. Okay, tomorrow 5 p.m. to take a screenshot, create a PDF, and then send the PDF to me. Okay. So this is the individual practice you have till 5 p.m. tomorrow. Okay, keep that in mind. So quickly take a screenshot, someone, and give me a yes in the chat box. Absolutely, thank you. Payal, you raised a hand. Go ahead if you have any question. Okay, no problem. So with this, people, we come to the end of our